Good morning, guys. Yesterday we have discussed about the Mach number, Mach angle. Today we are studying about the stagnation point. Okay, stagnation point. It is a point in the fluid stream where the velocity of flow is become zero and the kinetic energy is converted into the pressure energy. Okay, remember velocity becomes zero, kinetic energy is converted into pressure energy. Stagnation properties. These are the values of pressure, density, and temperature at a stagnation point is called stagnation properties. That means stagnation pressure, stagnation temperature, and the stagnation density. The equation for the stagnation pressure. Let us consider one flow. This flow is from one point to the second point. Okay. Let us consider a steady flow passed on immersed body under frictionless adiabatic or say isentropic condition. Consider 2.1 and 2 on the steam wheel. Okay. Let us consider P1 is the pressure of compressible fluid at point 1. Rho1 is the density, T1 is the temperature, V1 is the velocity of the fluid at point 1. Similarly, P2, Rho2, T2 and V2 are the pressure, density, temperature and velocity at point 2. Now applying Bernoulli equation for adiabatic flow at point 1 and point 2. So we are getting gamma upon gamma minus 1. This is because this is the adiabatic flow. That's why we are consider gamma upon gamma minus 1 into P1 upon rho 1 into G plus V1 square by 2G plus Z1 is equal to gamma upon gamma minus 1 into P2 upon rho 2 into G plus V2 square by 2G plus Z2. Okay. Similarly, if the elevations are same, that means Z1 is equal to Z2. So gamma upon gamma minus 1 into P1 upon rho 1 into G plus V1 square upon 2G is equal to gamma upon gamma minus 1 uh, gamma upon gamma minus 1 into P2 upon rho 2 into G plus V2 square by 2G because and this Z1 and Z2 will be cancelled. Okay. At point 2, at point 2, the fluid velocity becomes zero and the kinetic energy is converted into pressure energy. So point 2 is the stagnation point and P2 rho 2 is the stagnation property. That means P2 is converted into P naught and rho 2 is converted into rho naught and V2 is equal to 0. So we are getting gamma upon gamma minus 1 P1 upon rho 1 plus V1 square by 2 is equal to rho upon rho minus 1 into P naught upon rho naught plus 0. So if we consider these two terms of the same common term, so gamma upon gamma minus 1 go from, let us consider it is a common term, so we are getting P1 upon rho 1 minus P naught upon rho naught is equal to V1 square by 2. Okay. And if we take P1 upon rho 1 as a common term, so we are getting 1 minus P naught upon rho naught, P naught upon rho naught into P1, sorry, rho 1 upon P1 is equal to minus P1 square by 2. Okay. Similarly, gamma upon gamma minus 1, P1 upon rho 1 is equal to 1 minus P naught upon. That means we are just to consider these pressure terms in a similar way, means in a numerator and denominator, and rho are numerator and denominator. So we are getting gamma upon gamma minus 1 into P1 upon rho 1 into bracket में 1 minus P naught upon P1 into rho 1 upon rho 1 is equal to minus V1 square by 2. But for the adiabatic process, P upon rho raised to power gamma is equal to constant. So P1 upon rho 1 raised to power gamma is equal to P naught upon rho naught raised to power gamma. That means P1 rho 1 raised to power gamma upon rho naught raised to power gamma is equal to P1 upon P naught. Or say P1 upon, sorry, rho 1 upon rho naught is equal to P1 upon P naught raised to power 1 by gamma. That means we are just converting this this converting rho 1 rho 1 upon rho naught raised to power gamma is converted into P1 upon P naught raised to power 1 by gamma. So just putting this value in equation 8.13 means here we are just putting the values. So we are getting gamma upon gamma minus 1 into P1 upon rho 1 1 minus P naught upon P1 into P1 upon P naught raised to power 1 by gamma. And if we are just reciprocate them, means the value is 1, if we are say the values is 1 by a raised to power minus 1, then both are equal. So we are just converting them. So we are getting P naught upon P1 into 1 minus 1 raised to power 1 upon gamma. Okay. Or say 1 minus means this whole term is putting here, and this term is transferring to the this side. So we are getting 1 minus P naught upon P1 raised to power gamma minus 1 upon gamma is equal to minus V1 square by 2 into gamma minus 1 upon gamma into rho 1 and P1. Okay. For adiabatic process, the velocity of sound is, we all know that velocity of sound c is equal to under root of gamma into r into t, or say rt means we are using p upon rho, p upon rho is equal to rt. So just we are converting this, this rt is converted into p upon rho. So we are getting gamma into p upon rho. Say at point first, C1 is equal to under root gamma into P1 upon rho 1, or say P1 square is equal to gamma into P1 upon rho 1. Therefore, P1 upon rho 1 upon P1 is equal to gamma upon C1 square. So, so we are just converting this term. Okay, P1 upon rho 1 upon P1 with this term. Okay, this term. So we are getting 1 minus P naught upon P1 raised to power gamma minus 1 upon gamma is equal to minus V1 square by 2 into gamma minus 1 upon gamma into gamma upon C1 square. Okay, here gamma and gamma are cancelled out. So we are getting, okay, we are just transferring this to here and this term to here. Okay, so we are getting V1 square by 2, V1 square by 2 into C1 in C1 square, okay, into gamma minus 1. This plus 1 putting here, okay, is equal to minus is shifted here to it become plus. So P naught upon P1 raised to power gamma minus 1 upon gamma. Okay. Now, V1 upon C1 is converted into Mach number. So, M1 square into gamma minus 1 upon 2 plus 1 is equal to P naught upon P1 raised to power gamma minus 1. Or say 1 plus gamma minus 1 upon 2 into M1 square raised to power gamma upon gamma minus 1 is equal to P naught upon P1. So, this is our stagnation pressure. P naught is equal to P1 into 1 plus gamma minus 1 into 2 into M1 square raised to power gamma minus 1. Okay, this is the stagnation pressure. Then after we are discuss about the equation for stagnation density, which will be discussed in next lecture. Okay, thank you for your concentration.